Today I'm going to cover session 2 of the Python sessions. We are going to be talking a little bit more about how to manipulate the data, and then I'm going to show you kind of how you can apply Python for things like machine learning and what I guess is referred to as AI in the media. Just a quick introduction. So let's just click in to the Python sessions folder. Let's click on session 2 and start with module 3. Just as a heads up, what we covered in the first week, you can click into this exercise here in order to kind of brush up on a lot of those functions and the different content that I covered. So please try that out on your own and see if you can get that to work. And we will go over that in actually the upcoming session. But what I want to cover in this video is module 3, and we are just going to be doing this in a similar fashion that we did in the first session with the notes here on the left and then our Google Colab notebook on the right. And so first we need to import libraries. You'll notice that this is a new library. Matplotlib is a graphing library, and I think you are already familiar with pandas, which is kind of a data manipulation library. So these two libraries actually are incredibly powerful and can do a lot for us, both in terms of analysis and manipulating data. The data set we're going to use today is on GitHub. So I included this screenshot just as like a how-to for how you can actually download data directly from GitHub. So you'll notice that this is a New York Times GitHub that has actually all of the COVID-19 data. Actually, in this case, I'm just looking at Access Deaths, which was for, I think, an article that was written by them. And I'm clicked on this CSV file. This is just a type of file you can open in Excel. And once I'm on this file, you'll see this little button here. And if you press that little button raw, then it will bring you to another screen. And from that screen, you can copy and paste the URL, and the URL will look something like this. You know you did it correctly if this little raw is there, and you know you did it correctly if there's some kind of file extension like CSV or Excel here. So we can just copy and paste this whole thing. And again, this URL is just a string. So we talked about that last week. Strings can be printed off by just typing in the name of the string or typing print in the name of the string. And you can overwrite strings by just setting it equal to that name. So if I did this, we would get a new name. But we want to have this URL there because we're interested in reading that CSV file. So I'm just going to break this up. The PD read CSV function from the pandas library. You know it's from the pandas library because it's PD. So read CSV reads CSV files, as I showed last week. And we can see here that that actually worked, but we want to actually save that as well. So we're just going to set it equal to a data frame that we want to name df. So I ran it, and it looks like it ran. How can we see the data? Well, we can use the head function and various other functions that we covered last week, like tail, info, and so on and so forth. So feel free to review those on your own. And the first thing I want to show you is some very basic graphing. So first, I want you to select any country. I mean, on your own, you don't have to select Austria, but this is just for the point of exercise. I want you to select Austria. So we can select a column by typing in the name of the column. So let's show the first couple rows so we know what column names we have. So we have this country name, and I can also select this country by using the log function, which we covered last week. And so once I have that selected, I can also attach this unique function. And then this will give me all of the unique countries in our dataset. And so I'm going to create a mask. This is something, again, that we did last week. The mask is simply asking every single row in the country column whether that row is equal to Austria. So it will be true if the entry is Austria and false if not. And it looks like the first couple rows are indeed Austria. So this looks right. And then we can save that mask. So if I just save it, all it does is save that data there. So it's the same exact output. And then I'm going to create a new data frame called df_a by putting in this mask in the lock function of our original data frame. So just make sure that those names are correct. If you tried putting the A here before we created the data set, that's not going to work. Make sure that the data set already exists before you create it, obviously. And then we're going to stick that mask in the row column. Remember, the left side is the row, the right side is the column. So if we wanted to select columns, we could put something here and put names of the rows we wanted to select, but I don't want to do that for now. So I'm going to run that. And okay, what happened? Well, we have to see that df_a data set. And it looks like the first couple rows are Austria and the last couple rows should be Austria as well. So it looks like it worked. We only have Austria. How can we check that only Austria is in there? Well, we can use this. We can just copy that on there. And it looks like only Austria is in our data set. So that worked. Now I want you to further subset the data. So selecting only certain columns. So we can do that this way. Now we only have the start date and the excess deaths. I broke this into two parts, but you can do this whole entire thing in one go. If you, this is the same exact result. Okay. Okay, so now I want to introduce a new concept, and that is, I actually probably should be using these headings just for clarity. So let's set the index, and I'll explain very briefly what that means. So the index, as you can see here, is on the left side. So if I type in the name of a data set and index, it will actually print off what that index is. So in this case, it's a number that starts at 0 and it stops at 7,258. For a data set A, the index is a number that starts at 0 and ends at 303. What does that mean? Well, let's take a look at the tail of these data sets. What you'll notice is that the number, it's numbered on that left side there. So it's 7,257. So it's exactly, well, it's not exactly the same because the numbering in Python is a little bit wonky, but you can see that it goes up to more or less that same exact number. And data frame A will be the exact same. So in this case, it's going to go up to the number 302, or excuse me, 303. You can see there. So it's just like a numbering system, okay? But oftentimes, instead of these numbers, we actually want to have dates. So that's why I'm introducing you to this concept. Let's clean this up a little bit. So what we're going to do is we're going to set the index. We're going to make this the start date column. We're going to put that into the index and then erase these numbers. So it's actually a really easy process. All you have to do is type in the name of the data frame. You have to type in set index, and then you have to type in the name of the column. So as you can see now, there's no more 0, 1, 2, 3 numbering on the side as there was before. this number has been erased on the left and the start date has been moved over. Okay. Why did it just show me? Why is it not saved? Well, it's because we didn't overwrite the data. So in order to overwrite the data, we need to set it equal to the data name, right? And then run this and show that it worked. Okay, looks like it worked. We can confirm that it worked by typing in the index, and it looks like it's now dates. Okay, so that worked. Why did I want to do that? Well, when we're graphing a line plot, we generally want to set the time, whatever time that we're working with, as the index so that it can plot that down below. So it's really for these time series data sets that we want to do this for. So let's take a line plot. So I'm just going to over a little bit, created a line plot here. And so now we can see that that excess deaths, that data there is now being plotted, right? And it with the dates below and the number, right? I kind of just noticed something a little wonky though. It looks like the dates are actually going backwards. So this is actually a mistake. And there is a way to correct that. So the way to correct that is to sort the index. So we want to sort the index first. All we have to do is type in sort index after the name of our data set, and it will now sort in the proper direction. But we want to make sure that that sort remains by setting it equal to our data set. And sure enough, now it worked. Now we can plot it again, and it looks like it worked, right? Yep. So the earliest date is there, and the latest date is there. So now we are in business, and that is how to do a line plot. And I think I will show this later, but you might be wondering, well, how do I change the index? You can reset the index by just typing in reset index and then overwriting it. And then the data set will, once again, have an index that is one, like a number instead of a date. Right, now that start date is no longer the index. All right, so now let's try to plot multiple countries. Just here. I want to show unique countries again from our data frame. I kind of recommend you actually type in different countries to try to see if you can get it to work. I'm going to create a countries list, and inside of that list, I'm going to put, that list I'm going to put inside this is_in function. So I covered this before, but let's just do a quick refresh. Is_in is just a mask. So I need to save the countries first. So is_in just asks each row whether it is in this list. So France and Finland, the rows of France and Finland will be true and all others will be false. And I'm going to save that as a mask. And then I'm going to put that mask. Let's just do this next one. So did it work? Well, let's check it out. It looks like we have Finland. I'm sure France is down below. Looking at the end, looks like it is. And we also just only have the start date, country, and excess deaths. So now we can confirm that it's only France and Finland by just showing the unique countries. And next I want you to do a pivot table. So this is, again, review from last week. I want you to try to get Finland and France as the columns, and then have the start date as the index and excess deaths as the values. So we can do that by typing in the name of our data set, so df sub, is what I named it. I'm going to type in the pivot table function with the columns as the country. So this is the data that I want to have be up there. If I had more country names, if I didn't select countries, I would have all of these countries as different columns. I want to have the index now as the start date. So now we know what an index is. Last time when I showed you this, we didn't yet know what an index was. And then I'm going to have the values as the excess deaths. Okay, so let's see what this does. And it looked like it worked. And let's just add on another country just to drive home this example. Now we have Switzerland in our data set. And now you'll notice that we have 3 columns. Okay, and we can also try to even select a different data set. So what were the original columns from our original data set? Frequency, excess death, expected deaths. So let's say we wanted to have, instead of excess deaths, expected deaths. We would put that there. So now we would have expected deaths. And if we wanted to get that data, we would have to change the values to expected deaths. And then we would have now a data set with all 3 countries, but instead of excess deaths, we have the expected deaths. All right, so let's change that back. So what happens if I don't change this? Well, we don't even have a column anymore that says expected deaths. We only have excess deaths. So you got to make sure that this line up, because at the end of the day, this is the values that we want to grab. And it looks like it worked. So now we can save that data. I'm just going to overwrite the data, which is not always the greatest idea, because then you can't original data, but we'll just do that. So now we have made that pivot table. And I want to just show you that when you look at this data set, you can see that the index is not numbered. It has actually dates. So we can confirm that by typing in the name of our data set and the index. Now it'll show us the first couple rows. And now we can make a cool plot. So the first step is all we have to do is take that name of our data set and type in plot, and it will show you excess deaths by each country. So it looks like France didn't do so well during the pandemic, whereas Switzerland and Finland did a lot better. And we can also append to this so many different manipulations to the graph. We can, for example, add a title, we can add an X label, we can add a Y label, we can mess with this legend here. So let's just introduce it one by one. So this is a space for a title. So you can title it whatever you want. You type in PLT. And so you might be wondering what PLT is. Well, if we go back up to the top, you'll notice that I imported this library as PLT. So essentially that's similar to pandas, just allowing us to access functions from this library. So I type in PLT title, PLT X label, and now that's been changed to date. Before it was start underscore date. So the customization is really nice for this. Excess deaths is now the Y label, and I am now putting this legend in the upper center. This LOC I think stands for location. And then that's our chart. So that's a line chart. We can also make bar charts. I'll show you how to do that. So I want to subset data from our original data set. Let's again just refresh our memory what that original data set looks like. So what I'm going to do is type in the start date. So that's the name of this column. And I'm typing in unique. So this will give me all the unique start dates. And I noticed that it started low and ended at the last start date. So I showed a list of the last kind of start dates here. And so what I ended up deciding is that I want to grab only the start date that is equal to 2020-01-13. So I'm just creating a mask. And what is that mask going to tell us? It will be true for all of the rows that are of this start date, right? So you can see here, this is January 6, 2020, which is not what we're looking for. And as a result, it's false. 2020-01-13, that's this, and it's equal to that, so it's true, okay? So that's all I'm doing there. And then I'm just creating a mask. So that's all I did here is just create a mask. And then I'm sticking that in this lock function in the proper row, and then I'm selecting certain columns. You can see that it worked. So you'll notice that this looks a little bit different. Well, that's because I no longer have so many data points. I've only selected the data points for this date, and that's why it's a lot smaller. And so I want to save that as this new data frame called GF bar. And so now I want to set the index. You can set the index by using set index function and type in the name of the column you want. Now you'll see that these numbers on the side are gone and they're replaced by the country. And we want to override our data set so it looks good. And as I introduced earlier, you can reset that index. You can reset the index by setting it equal to the name of the original data set and then dot reset index. And then you should see that that data set goes back to having no index and the country will be the column. But I don't want to do that because I already showed you how to do that. So I'm just going to move on to the plot. So we have that data set named EF bar, and I'm typing in plot. But this time I'm going to type kind equals to bar, and as a result, this will give me a nice bar chart. So again, we can do similar customization as we did before, no problem. Just because it's a bar chart doesn't mean we can't do that. And yeah, now that shows the excess deaths by each country at the last date. So France, Germany, and the US didn't do so hot during the pandemic, according to this data. Okay, the last thing I want to cover is to cover resampling. So this is pretty interesting if you want to take some like daily or monthly data and make it yearly data, or if you want to make monthly data yearly data, or daily data monthly data, and so on and so forth. We're going to be using this COVID data set from the New York Times. Again, I got this by clicking on a raw button on the GitHub that hosts this US state CSV data. And I'm putting that into an object, and then I'm reading that CSV file. And I'm adding two new arguments, they're called. And the first argument is parse dates. So that basically gives us a special type of data set for the dates. And then I'm setting the index column. So this is to do with our index. And I'm setting that equal to date, which is the name of the date column. And so as a result, it's now spitting out a data set that has an index already. So I don't need to set index. It's already there. If I did not have that index column, I'll show you what it looks like. You'll notice that the date is there and the index is no longer a date. It's just a zero through, it's just a number. So let's go ahead and do that. Run it. And then I want you to drop some columns. So I want you to drop this FIPS column, and that's easily done by just typing in the name of the data set, drop, and then axis equals to 1. That's the column axis. So you'll notice if I run that, the FIPS column is no longer there. And I want to overwrite the data set. So I'm setting it equal to the data set name and dropping it. Now I want to reset the index because we're going to do a pivot table. So in general pivot table, you want to have the index reset. And so you'll notice now that our columns are all there for what we want to manipulate. And so I'm going to use that pivot table, setting the index as the date, columns as a state, and I only want to get the cases. So that I'm going to ignore that deaths data set altogether. And so now basically what this shows is all of the states by date, and the values here are the case numbers by the date, right? So I can overwrite that here. And you'll notice that there's all these NA values. We don't want those values, and we can easily drop them. So how can we do that? All we have to do is type in the name of the data set and drop NA, and then it will no longer be there. So all these data are then removed, all these rows. Close that. Now all that data has been dropped. And finally, we can do the resampling. So you just type in the name of the data set, resample. A stands for annual. So if I type just this, it doesn't, nothing comes out because I need to tell it how to aggregate the data. So I can tell it sum. So I can sum the data, and this will give me the yearly data. I can tell it to give me the mean. So this will give me the mean of the entire year. But I want to do the sum. And then that will just give me the 2021 and 2022. Let's overwrite the data. And then I have the data set that looks like that. And then I'm going to do one final trick before I do another plot. I'm going to transpose the data. Transposing the data basically flips it. So these columns will become the rows and the rows become the columns. I'm going to do that, overwrite the data, and then I'm going to rename these columns by typing in dot columns equal to the names that I want it to be. So if there was 3 columns, I would have to add a third column name. But because there's only 2 columns, I only have 2 names. Now you might be wondering, well, isn't this a column? That's actually a really good thing that I should have stressed earlier. The index does not count as a column. So if I run this line of code here, this data will be transposed. And then I can look at our columns by just typing in this, and you'll see that there's only 2 columns, right? The index is those dates. Okay, so that's the index. So we can go ahead and overwrite the column names by using the columns equal to this list of the new names. So let's do that. Now we have the new name there. And finally, we are going to plot that data. Oh, it looks like I had too many commas. So now we can see that this is a scatter plot with the 2021 data on the, let's see, x-axis and the 2022 on the y. So you can see there's a high correlation between the cases in one year to another. And I will cover this advanced kind of topic or this advanced way to download data next week because we're running a little long.